Okay, now hopefully this is going to be our concluding section or concluding session of this section. Okay, session 5, looking at electrolytic cell. We've done quite a lot. If you go back to your notes, it's been quite a lot. In depth, covered everything that I feel the examiner would bring across your way. So we started looking at electrolytic cell in our last week. So this is about the part 2 of the electrolytic cell. However, for just about 5 minutes, let me bring back to your memory the things we said about electrolytic cell. Where is our notes? Quite a lot of notes so far. Beautiful. So we looking at electrolytic cell. Look, a quick way to remember a lot of things is to first look at the name. Electro. What word are we starting with? Electricity. That should tell you we are taking electrical energy and converting it into chemical. That's what I think about. Electrolytic. So I'm using electricity to produce what? Chemical change. All the few points we said. Number 1, it is non-spontaneous. Therefore it is endothermic. Electrons are driven by a DC power supply, and when we say a DC power supply, it's a direct current power supply. And why DC? It's an exam question. It keeps the polarity unchanged as current flows in one direction. That we take from paper 1 under electrodynamics, alternating and direct current. Electrical energy, can you see what I was saying? Electrolytic. So we are converting electrical energy to chemical energy. Electrons move externally. We know that from the anode to the cathode. Whether it's a galvanic cell, whether it's an electrolytic cell, electrons will always move from the anode to the cathode, alphabetical order, A to C. APE, very important thing you need to remember. The anode is positive in this electrolytic cell. Then we came to our definitions. Electrolysis, the process of converting electrical energy to chemical energy. What is an electrolyte? An ionic solution that conducts electricity through the movement of ions. Remember the song? If you listen to that song, you will notice that this is just the lyrics. If you've listened to it, this is just the lyrics. Then we spoke about conductivity. This is an extra information that an examiner can throw your way. Conductivity increases as concentration increases. Why? If we increase concentration, we increase the number of ions present. And it is these ions that carry what? Electricity. Is that okay? So the more ions we have, the better the conductivity. Hence, number 1, concentration increases what? Conductivity. Number 2, the strength of the acid. Going back to acid and base, there's strong acid and weak acid. Strong acid is an acid that ionizes completely to produce a high what? Concentration. Again, I am going back here. Concentration. A high concentration. Once I have high concentration, I'll have high number of ions. Conductivity will what? Increase. And the major thing is that more ions are present. Lovely. Process of electrolysis. 3 processes. No matter the cell we're looking at, we're going to follow these 3 processes. Number 1, the breaking down of ions. Number 2, the movement of ions. And when ions move, like we said, cations will always go to the cathode. Cat. It remains. Whether it's a galvanic cell or an electrolytic cell. Cat, an. And number 3, redox. Now, this is what we want to explain today. How this will then be applied. We said application. I want to look at these 4 cells. Please go with me, because I'll be repeating the same thing. Is that okay? I will be repeating the same thing, but now we'll be seeing how it works in each of these cells. Today, let's start with electroplating. Electroplating. Okay. Oh, why is question so early? Let's go to electroplating. You know, when I was growing up, my mother used to have these spoons. I don't know whether your parents do. It's only meant for visitors. In my house, it was gold. Okay. So my mother never allowed us to use those things to eat. So I used to think that the food tastes differently. So one day when she was not home, I went and I stole one of those precious golden spoons. I saw that the food tasted the same way. Only now that I'm doing chemistry, then I remembered, my mother was scammed. Shame. Old woman. She was scammed. They scammed her by telling her that those things were gold. All right. Just like us, you know. We gave, you know. So why do we electroplate things? For appearance. Makes sense. To make it look good. Okay. But the first thing is, what is electroplating? So we're looking at electroplating. It is the process of covering a metal with another metal. Electroplating. The process of covering a metal with another metal. The process of covering a metal with another. The process of covering a metal with another metal of high resistance to oxidation. For the purpose of 1. Protection from rust. Rust is basically oxidation. When something is rusted, we say it's oxidized. Number 2, for appearance, better appearance. And if something appears better, then it has economic value. Make sense? All right. We can add for better appearance. Number 3, to increase economic worth. That's why they lied to my mother and sold those spoons very expensive. I wish I was grown when she bought those spoons. I'll have told her, no, Mama, they're lying to you here. These spoons are normal spoons. Okay. So this is why we electroplate. We cover a metal with another to prevent it from rusting, for better appearance, for economic reasons, you know, all of those. Now, in the process of electroplating, just take a few notes. We're not going to write so much. In the process of electroplating, the following are considered. 1, the material to be electroplated is at the cathode, the negative terminal. So if I want to electroplate a spoon, the spoon should be put at the cathode. And I'll tell you how I remember this. Electroplating a spoon means if I want to electroplate with gold, it means I want to see gold on the spoon, right? It's not real gold. The spoon is not gold, but I want to cover it. So it is to see gold. And still on number 1, I usually write, we see at sea. We see at sea. Why sea? Because reduction of ions to solid by gaining electrons. So the cathode would gain what? Electrons, and once that happens, the ions are then reduced to what? Solid. For example, check. I could say Ag plus E to give me what? Ag. I am producing a solid. This one is aqueous. This is invisible. But this is visible. So to cover a metal, we need to have that metal reduced. Reduction must happen there so that the invisible is converted to something you can see. Oh, we see. At C. What does my other C stand for? We see at the cathode. So if I want to see gold on a particular metal, that metal or material must be connected to the cathode, because I am going to see at the cathode. I can only see something solid, something visible. Visible, I see a solid. Make sense? I see a solid. Guys, do you understand what I just explained? And with that, I hope you'll be able to remember. I see at the cathode. We see at C. C for cathode. That's where reduction takes place. Reduction is basically converting ions to solids. Let me know if we are okay, because I'm almost done. Before you know it, I'll be done. Okay. Important things. Number 2. We use the electrolyte type of the material of covering. Of covering. I'll explain that. What happened? Of the material of covering. That is, to cover or electroplate, let's use a chemistry word, with silver, we use a silver electrolyte. To cover with gold, we use a gold electrolyte. To cover with platinum, we use a platinum electrolyte. Remember, electrolyte is the solution. All right? So we use the electrolyte type of the material of covering. Number 3, we use the anode metal of covering. That is, to cover with silver, then the anode must be silver. This is to prevent contamination. If I want to cover with gold, so you have silver in a silver electrolyte. Does that make sense? If I want to cover with silver, the anode must be silver and the electrolyte must be a silver salt. And the last point, number 4. Number 4. Then we can look at that entire process as quickly as possible, answer questions. It's going to be the same process like I said earlier on. So please, once you get one, you get the other. Can I move on? Let's see, can I move on? Hi, Spartley. Okay. Number 4. number 4. All right, what will my number 4 point be? And then we will just look at the process. Number 4. If the material to be covered, if the material to be electroplated is not a metal. Example, I want to electroplate, not a spoon, a shoe. Maybe one of your mentors, a hero, you just bump into their shoes and you want to keep a legacy, okay? And the best way to do it is to electroplate it. We cover the metal, we cover the material with graphite, which is carbon. All right? Graphite is a semiconductor and inert material, because we said our electrode must be a conductor. Remember, electric rod. Okay, so these are the important points that we have. Okay, so example, just one example. Let's cover a ring with silver. Let's cover a ring with silver. What do we need? We need the ring itself, and the ring becomes the cathode. We need a silver anode. And number 3, we need a silver electrolyte. And I told you the best electrolyte is to use silver nitrate, AgNO3. All nitrates are soluble. Remember, this is going to be my negative end, while this would be the positive. So my cell would look something like this. Now, I want to put this on the side because I don't want you to think that that would always be the anode. All right, so I have my ring that I want to cover there. I'll have my beaker. And then I'll have my conducting material or a wire. Okay. Since the cathode is where I want to put my material, then that has to be the negative, the short end, while the long end must be the positive. Don't forget, whatever I want to electroplate must be at the cathode. And I drew it this like this so that you don't think whatever I want to electroplate must be on the right. It doesn't matter. Okay. So this is positive, and this is what? Negative. Now I'm going to have my solution. You see, I want to cover the ring, so it must be in the solution, embedded in the solution. Now this is going to be what? Silver. And my electrolyte would be what? Silver nitrate. This is what my setup would look like. The ring will be the negative. I want you to listen to this process quickly. All right. What is step 1, if you remember? If you go back to your notes, what did we say? The breaking down of the electrolyte, right? So, my silver nitrate, I'll give you time to write, please just listen quickly, would break down and give me what? Ag plus NO3 minus. Look at it. I hope you're listening, you're not writing. Ag plus. Mind you, don't forget that this one is what? Negative, right? Don't forget that this thing is negative. Oh, this thing is negatively charged. Negatively charged. While this one is what? Positively charged, because it's connected to the positive end. Under electrostatics, what are we expecting? Unlike charges will do what? Attract each other. What do I have in the solution? Check. We said Ag plus. So Ag plus and what? NO3 what? Minus. Do you notice that this positive one will move towards the negative? Why? Opposite charges will do what? Attract. And don't forget that the plus one are my what? Cations. They must go to the cathode. I don't know if you see that. It's making sense. That this is the cathode. And my cations, Ag plus. This is my anode. And what goes there? What is attracted? Anions. Here we have that. Does that make sense? Cations would go to the cathode. Anions, let me draw that arrow in the other direction. Anions would go to the anode. Anions. I'm going to be slow on this first process, but the second process, I'm not going to be this slow, because it's the same thing. The anions would go to the anode, and the cations will move to the cathode. Already I've done step 1 and step 2. Step 1, breaking down of ions. Step 2, migration or movement. Let's call it the movement of ions. Movement of ions. The cations will go to the cathode, and ions would go to the anode. Step 3, my beautiful learners, we talk about reduction. I want you to listen to this part. What happens at the cathode? Now, at the cathode, remember what I have. I have Ag plus, all attracted here because of electrostatics. The positive going towards the negative. Okay. Because I only have silver there, we're using a very less reactant ion or metal as the ring. At the cathode, what are we expecting? Reduction, red cat, which is what? The gaining of electrons. Oh, but what do we have at the cathode? Silver what? Ions. They are now there. Remember, at the anode, what happens? Check this. I'm trying to animate and give you all the steps. Electrons are moving away from the anode. You see, negative attracted to the positive. But electrons are leaving there and coming here. So, what's happening? The silver ions are gaining electrons and become what? Silver what? Solid. And that's the aim. That's all that I want. And somebody's saying, but really, sir, where are the electrons coming from? My beautiful learners, what do I have at the anode? Check. At the anode, what do I have? I have silver solid. Is that fine? That's a silver solid. And I have what? Nitrate ions. Please, this one is very key. I'd like you to get this. Nitrate ions are here because they are negative, right? But what happens at the anode? Oxidation. Let's go to our table. and find out which one will be oxidized. What are we comparing? We are comparing silver and nitrate ions because both of them are there. The electrode is silver, but what it's like your visitor, if a visitor visits you, your friend visits you. How many of you are at home? It's 2 of you. You must count yourself. So it's me and my visitor. So this is me and this is my visitor. But at this electrode, we are expecting what? Oxidation. Let's check our table quickly and see which one is oxidized. It's a long process, but if you get it, you get it once. Going back to our table, which we've done. What did we say? The first one we find will be the one that is oxidized. Remember? Good. Ta-na-na-na. We are looking for silver, right? Is there silver here? No. Oh, no. Silver and NO3, nothing. Come, let's continue. All right, good. Somebody's going to say, but there's NO3 here. And there's silver here. And then we have another NO3 here. Okay. Now, let's check again. All right, beautiful. Let me let this thing die down for a second. So don't forget, we are using what? Silver. Is that okay? Good. Now, there is NO3 here and there's NO3 here. The fact that we have NO3 here, it means this will be oxidized because NO3 is at the bottom. Is that okay? I am seeing silver and I'm seeing NO3. This one would be the anode. So this one would be oxidized. Please listen. Silver will be what? Oxidized. What does that mean? And I will be done and ask you if you are okay with what I've done. Silver will be oxidized. Can you see we have silver there at the anode, which is oxidation, which is what? The loss. Silver, Ag solid, will be oxidized to what? Ag plus. So it's releasing an electron. Please get the process. We have silver. Okay, the first process. I've spoken a lot, I've said a lot of things, and you might just be lost. Let me go back now quickly and put the whole thing. Please put the whole thing in 2 minutes. First, we have a setup. We have silver nitrate. It breaks down to silver. Let me put an arrow there. I don't even know how you're going to write this. Just take a picture. But mostly it's to understand the process. Silver nitrate, that's what we get. All right? The silver nitrate, which is plus, the silver plus is attracted to the negative electrode. The NO3 nitrate is attracted to the positive. At the negative electrode, what we have? We have the ring and silver ions. What happens? Reduction. What is reduction? The gaining. The silver ions that are there would gain electrons. Wait, where are these electrons coming from? They're coming from the anode. So silver is oxidized to produce silver plus. I'm going to explain something there. Plus electron. The electron they produce goes this way. The silver ion here receives the electron. We have reduction, solid. Here we have what? Oxidation. And that is the process. I want to talk about a few things later, but let me know if you understand the process. The 3 steps. Number 1, breaking down. Number 2, migration. Number 3, oxidation and reduction. I'd love to take your questions if there is any. Sitle, ask. Try to listen to everything I said. Everybody seems to be okay at home. Revisit the process in your head. The anode, silver, will be divine. Silver will be oxidized. Okay? Silver will be oxidized. Metals are always oxidized. Silver will be oxidized while NO3 will remain in the reaction. Yes, that's what I'm explaining now, right? So I am using the NO3 at the bottom because it's present there. NO3 is present at the bottom, all right? So silver is a solid which is oxidized. Mostly we oxidize solids, all right? It's a stronger reducing agent than NO3. So silver will be oxidized. Is that okay? And let me quickly, Divine, let me show you what will happen. Hold on, guys. Let me do this so that you can see what will happen. And it's going to make sense to you just now. Come on board. Don't worry, I have this page duplicated. I want to do something. I want this to be on the same page. Just give me a second. All right. Come on me now. I'm going to put the process and the on the right hand side of the process. The process is not responding. This may end the process. Never. Guys, wait. Just a second. Just a second. I might be losing this note. Ooh la 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 la. If you want to take a screenshot, please take it now.